In this video, we're going to test the algorithm that we just wrote. We're going to be counting from 0 to n, and n is a variable. We're going to draw boxes for each of our variables to keep track of what value they currently have as we step through our algorithm. As we begin, n has the value 5. The other thing we're going to keep track of is the output of our program. Here is a box labeled output, and every time we write something down, we're going to write it into this output box. Finally, we're going to use a green arrow to keep track of where we are. Right now, the arrow is right before the line that says count from 0 to n, which means we haven't done this yet. Now we can start. The first thing we want to do is count from 0 to n inclusive and call each number that we're counting I. Since I is a variable and it's going to start with the value 0, we create a box to hold I and its value of 0. Now we enter the next step. The next thing we're going to do is write down n squared minus 2 times I. We have a little bit of math to do here. N is the value 5 and I has the value 0. So this gives us 25 minus 0, or 25. And again, we're supposed to write this number down. So we place this number into our output box. Now this process is going to repeat again and again. Now I is going to have the value 1. Once again, we're going to compute n squared minus 2 times I. This is the same as last time, except I has the value of 1. This is 25 minus 2, or 23. We write that to our output box. Now we just completed I equals 0 and I equals 1, and we're trying to get all the way to I equals 5. So now we're working on I with a value of 2. Once again, n squared minus 2 times I, which is 25 minus 4. The value is 21. And we will write this to our output box. Now we're working on I with the value of 3. We're going to write down the number. N squared minus 2 times I, 25 minus 6, which is 19, into our output box. And we're going to keep doing this, for I having the value 4, which is 17. For I equals 5, which is 15. I keeps getting larger each time we step through our algorithm. When I equals 6, however, we're going to stop because we're only counting up to n equals 5. At this point, we've finished the entire algorithm. And the good news is that our answer matches what we were expecting. The sequence of numbers is, in fact, what we were hoping to produce.